is fundamental to the very basics of life. It builds on the knowledge of a person who develops his or her ability to think logically.
Maths has helped me a lot. To be honest, ever since Mr. Oscar taught me math, I can read time, calculate bendings, and score higher in every subject, whether it is art, physics, economics, or even sports.
Recently, I've taught Maya, a student of mine, some math, and helped her improve both her practical knowledge and also her ability to cognize rationally.
Math is important to art in many ways, but one example would be when an artist is creating a large-scale public artwork. Depending on the materials and depending on the space that's involved, artists will need to use math and engineering in a sense to decide what scale is appropriate for the buildings and for the space that it's in. Day to day in the classroom, we also use math when doing grid drawings or when translating a drawing from a small drawing to a big drawing, because we need to know the scale and get the right proportions.
The reason why it's important is because formulas are used to create models, and mathematical formulas are what are utilized for those models.
Math is very important to physics. In fact, there's some areas of math that were just invented to help physics. Physics and math go hand in hand. I think math and physics are bridges to one another. To be able to speak physics, you have to know some math, and to be able to speak math, you need to know some physics.
Math is very important in sports in many different ways. There are some sports that are very statistics based, i.e. baseball, American football. They have stats on performance, they have stats on hitting, they have stats on field goal percentage, so forth. When you're looking at strategies of games, you're looking at angles, you're looking at percentage of winning, percentage of possession. So when you're looking at strategies in sports such as football, it's very, very important.
So it's very important to acquire language for math. Math has a lot of subject-specific vocabulary, and so it's very important to learn all of the different terms and vocabulary. Otherwise, you can't understand the questions, you can't understand the problems, and you can't understand how to solve the problems. There are a lot of abstract concepts in math, and the ability to actually see a physical model for especially geometry can be very useful for students who learn visually.
The way I interpret it, models being real-world application of your knowledge and try to apply mathematics to real-world models and more. So they are important, and it helps you to retain knowledge and see how the knowledge you learn is applicable to the real world.
Some of the key points in significant developments of math are with space and discovery, and mathematics has been always thought of with space and predicting solar eclipses and predicting where the universe started from. And without mathematics, we couldn't do that. So a lot of mathematicians have studied over time where everything came from, and the beginnings and the ends and calculations, and we are where we are today with artificial intelligence and everything because of mathematics.
History plays an instrumental role in math. Mathematicians like Algorithmic, the father of algebra, Fibonacci, the founder of the Fibonacci sequence, or Pascal, the creator of the Pascal triangle, all contribute to the database of math rules and functions that we must follow today.
The key points in the historical development of this area of knowledge, I really haven't got a clue.
Math is essentially just connecting numbers together in a logical way. It simply is just linking two ways of knowledge together. Memory, to remember the set rules of math, and logic, to use these rules and deduct a solution to a math problem.
I think most of the major advances and achievement in mathematics have very often come from an individual. You have people like Isaac Newton.
Isaac Newton came up with calculus to help him solve some physics equations, so integrals, derivatives, etc. Are all down to Isaac Newton wanted to solve some physics equations.
Dating all the way back to someone like Pythagoras and everywhere in between, and from the Eastern world, so many of the advances made in mathematics were built upon previous knowledge, but they were more often than not made by individuals, as opposed to other areas where advances may have been done as a group or collaboratively. In mathematics, traditionally,
as a fact in math. So in my opinion, a fact, speaking scientifically, is something that has been tried and tried and tried to be disproven, but you cannot disprove it. So the reason we do experimentation in science is so we're trying to see if something can be disproven. The more times you can't disprove it, the more likely it's going to become a fact. So I'd say the same thing about mathematics. Something that you can't disprove.